Hello everyone, in this lesson we are going to learn transformers, and in learning transformers we will use reasoning. The learning objective for today's lesson is you are going to be able to understand the operation of transformers, and also you will be able to solve problems using this formula. Let's start our reasoning. What is a transformer? A transformer is a device used to increase or decrease the voltage in a circuit. This is the photo of a real transformer, and this is the symbol for the transformer. Next question, are we using transformers in our daily life? Yes, in our refrigerators, washing machines, and other devices we use in our houses, all uses transformers to adapt the voltages. Also, we use the transformers in our computers, in our cell phones, so on and so forth. Let's look at how does a transformer work. A transformer sends an alternating electromotive force V1 through the primary coil. This is the primary coil, and this is an alternating current source, and an alternating electromotive force is sent through this coil. And then this causes an oscillating magnetic flux through the secondary coil, and hence an induced electromotive force is produced here. Let me show it by drawing magnetic field lines, and let's use this color. So when a current is flowing through this circuit, it will produce some magnetic field lines, and the magnetic field lines are going to be something like this. They are going to be magnetic field lines like this. We will have many magnetic field lines like this. So there is a changing current, and it produces a changing magnetic field, and the changing magnetic field is producing a changing flux here, and this flux produces some secondary current in the secondary coil. This is all because of the Faraday's law of induction. You can go to our previous videos to see how the Faraday's law of induction is explained. This is the formula to calculate the problems related to transformers. This represents the secondary current, primary current. This is primary voltage, secondary voltage, primary number of turns of the coil, secondary number of turns of the coil. This is the number of the turns in the coil. Are transformers 100% efficient? No, there are two reasons behind why they are not so efficient. If you use an adapter, for example, in your for your mobile phone, if you touch it, you'll feel that it's a little bit heated, and some energy is dissipated in the transformer itself. That's why they are not 100% efficient. Second, as I explained before, when the current through the primary coil is changing, it produces some magnetic field lines, and if you put another coil here, and the secondary current is produced here, so also secondary voltage. This is the primary current and primary voltage here. This is the V primary, and this is the V secondary. So as you see, what produces the voltage here is the change of the magnetic field, which is produced by this coil. But when you put a secondary coil here, not all of the magnetic field lines are passing through this coil, so it decreases the efficiency of the transformer. Then, related to this question, why we are using iron core and iron material as a core in the transformer. So if we place, let me show with another color, and let's show it with green color. So if we put an iron core here, and an iron core, assume this is an iron core, this is an iron core. This iron core helps all of the magnetic field produced from the first coil to pass through the second coil. It increases the density of the magnetic field lines, and in turns it increases the efficiency of the transformer. That's why we use iron here to increase the efficiency of the transformer. What are the types of transformers? There are two types of transformers: step down and step up transformers. This is a step down transformer. This is the number of the turns in the primary coil, and this is the number of the turns in the secondary coil. When the number of the turns in the secondary coil are less than the number of the turns in the primary coil, this is called a step down This is called a step down transformer. It decreases the voltage. This is the V primary and this is the V secondary. V primary is bigger than V secondary. Voltage is dropped. Step up transformers, on the other hand, the number of the turns in the secondary coil is bigger than the number of the turns in the primary coil, and this increases the voltage. This is step up. So V secondary is bigger than V primary. Why do we need transformers? First, different devices works at different voltages. When the current is supplied to our houses, it is a constant voltage. In our houses we have, for example, 110 volts, but our devices works at different voltages. That's why we need to change voltage. That's why we use transformers. Second, we use transformers in transmitting the energy. For example, the energy from the dam. This is the dam and this is the city. We are going to transfer energy from here to here. During the energy transfer, there's going to be some energy lost in the wires, and the energy lost in the wire, the power loss in the wire, is directly proportional amount of the current. That's why to decrease the power loss during the transmission, we need to decrease the current. To decrease the current, we are going to increase the voltage. That's why we use a step up transformer here, and in the entrance of the cities we are going to use a step down transformer. For example, the amount of voltage produced in the dam, assume it is 500 volts, and this is going to be 500 volts, and here will be some coils, primary coils. This is going to be some secondary coils, and for example, let's say we are having 50,000 volts. This is step up transformer, and we increased the voltage, and then the energy is going to be transmitted with high voltages, but with low current, and amount of energy lost in the wires will be decreased. Here we will have the primary coil, and here we will have the secondary coil. This will be 50,000 volt again, and it will be decreased to, for example, 110 volts, and we will use this voltage in our cities. Okay, let's look at some problems. The first question is, what is the voltage across the light bulb in volts? Here 120 volt enters this transformer, and here we have another transformer. We have two transformers. If this is 120 volts and there are two turns here, and the number of turns increased, this is a step up volt. This is a step up transformer. It increases the voltage. Number of turns is 2 times bigger than the number of these turns. It means here we will have 240 volts. These two are parallel to each other. This is also 240 volts, and number of turns here is bigger than the number of turns here, 2 times bigger. That's why the voltage is decreased. Again, it's going to be decreased to 120 volts. Second question, you hook up a 12 volt battery to a transformer with 1000 turns. If the other side of the transformer has 2000 turns, how much is the output voltage? In this question you should be careful. Now please see that it says that 12 volt battery, and we know that the current of the batteries do not change with the time, so there is a steady current in the battery. So transformers works only and only if there is an alternating current. So if you use a battery to step up the voltage or step down the voltage, it will not work. So the output voltage here will be 0. Let's look at the next question. So in this question, the electricity is distributed from electrical substations to houses at 15 kilovolts. Transformers in house devices step this voltage down to the 110 volt. The first question is, how many turns does the primary coil have if the secondary coil has 220 turns? Now for A, we are going to use our formula, V primary divided by V secondary equals N primary divided by N secondary, and we know that the primary voltage is 15,000 volts divided by the secondary is 110 volts equals number of the turns in the primary coil divided by in the secondary coil we have 220 turns. In making calculations, this will be 30,000 turns. B. Suppose a transformer delivers 150 ampere at 110 volt to your devices. What is the current in the line from the substation? It means it is asking the primary current. For this, we are going to use I secondary divided by I primary equals V primary divided by V secondary. This formula comes from P in equals P out. We assume that these transformers are ideal transformers, and input power equal to out power. It means input power I primary times V primary equals I secondary times V secondary. So rearranging this formula is going to be equal to this one, and we know that secondary current is 150 ampere, and primary current V primary equals current primary current, and V primary is equal to 15,000 divided by the secondary voltage is 110. So in making the calculations, I primary will be equal to 1.1 amperes. So let's look at one more question and then we are going to finish. A transformer connected to 120 volt line is used to supply a device with 6,000 voltages, and this is RMS voltage. The device dissipates 60 watt of power. What is the ratio of N2 divided by N1? So for the first one, we know that V primary divided by V secondary equals N primary divided by N primary divided by N secondary, and we are asked to N2 divided by N1. It means secondary divided by primary. So N secondary divided by N primary will be equal to V secondary divided by V primary, and it will be 6,000 divided by 120, which will give us 50. This is the ratio. B. What are the RMS currents in the primary and secondary coils? Now we know P in is equal to P out in ideal transformers, and we know that V primary equals I secondary V secondary, and we know that from here I primary times V primary is given 120 volts here equals I secondary times V secondary is given as 6,000 volts, and these are power, their multiplication equal to the power, and we know that the power is equal to 80. So from here we can calculate I primary is equal to 80 divided by 120, and it will be equal to approximately 0.67 amperes. I secondary on the other hand will be equal to 80 divided by 6,000, and this will give us 0.016 amperes. Next question, what is the effective resistance seen by the 120 volt source? And we know that resistance is going to be equal to V primary divided by I primary, because it asks it asks the resistance for the input for the 120 voltage. It is equal to 120 divided by I primary. We calculated 0.67. This is 120. 0.67. So if we divide them, we will get approximately 179 ohms. Okay, so I have a question for you. Why is iron chosen as the material for the core of the transformer? We explained why we use an iron core in transformers, but why not aluminium or copper or some other materials? Why we especially choose iron? So this is a question left to you. Maybe you can do some search and find its answer, and you can write your answers at the below of the video. Okay, thank you for listening. See you next time.